Hello, very good afternoon, my dear students. Welcome to BYJU'S Exam Prep. How are you all? Quickly join the session and please do let me know everything is perfect with the audio and video. Very good afternoon, very good afternoon. So before starting, let me ask you, how is your preparations going on for GATE and ESE? Right? Good afternoon, good afternoon. How are you? Very good afternoon. Let me cross check from my end. One second. Yeah, all perfect. Very good afternoon. So preparations up to the mark, practice. I think you should be now practicing every day for all the subjects, right? Hello, good afternoon, Shalom. Hello, good afternoon. How are you? I think your heat transfer is all ready, you know? All good. Okay, Bhavya. I think heat transfer is ready from your side also, because we have practiced a lot of questions. So it's a quick revision for all the very key topics, because this series is planned in such a way that we'll be revising and practicing the questions which is very important from the GATE exam perspective, because there are some selected topics in every subject that is must do topics you should be covering. You should not be leaving that topic, because that topic is considered to be the very important for GATE examination. I'm good. I'm good. Very good. Very good evening. After a long time, we are all meeting post Diwali, right? Okay. So before starting the subject, first of all, how many subjects completed? All completed. Revision part going on. Or 60%, 80%, 90%, how much percentage of subject completion has been done? Because now November has started, so almost you are having like 3 months at max, you're having 3 months with you, and in this 3 months you have to give your best for GATE examination. This is a huge opportunity for GATE 2022. Right, many PSUs have registered themselves prior to the GATE examination. This is the first time happening, and many seats has been declared by PSU for mechanical engineers. Right, it's good always. It's perfect that if you're starting for 2023, it's always to start early, because that will be giving you an extra edge over other candidates. And those who are preparing for 2022, I think it's a high time. Give your best for the next 3 months, because the more you delay the process, the more it will be hectic for you at the near the end days, right? Chali. Sir, 5 subjects completed, sir. Production, how to complete, don't know. देखो, production में you need to cover some important topics, important segments, which is regularly asked, just like I can say metal cutting, okay, casting, okay, your machining processes. So different processes that we are having. I think Onkar sir will be taking that. Fine. So don't worry, he'll be covering the important segments which is relevant and important for GATE perspective. Because production is that subject which is I can say it is not possible to cover the entire 100%. Every day there is some advancement coming up. So it is impossible to cover the 100%, but you have to cover the topics which is important 100%, right? So I'm third year student, what I need to do, don't worry if you're third year, if you're final year also, remember one thing, if you're preparing for 2023 also, make sure you are preparing just like you are giving 2022 in a best possible manner. Okay. Chaliye, so let's start to today's segment, and we'll be discussing about more about this very important topic, that is resistance analogy. So let me introduce about myself. Those who have sir, you stopped Tom series in app, please continue, sir. At least vibration topic. I think only vibration was left out. Vibration, gyroscope, cams, 3 topics was left out. I think governor also. These 4 topics was left out. So let us plan, because there are some changes happening in the classes. So let me plan something. Okay. Let's see how many free classes we can go right now. Okay, so those who are not yet connected with me, please do connect on this Telegram channel, that is Learn with Sooraj. Why I am saying this? Because all the faculties are connected with me and they are sharing their links, class links on this particular Telegram ID. Okay, chaliye, so these are the complete mechanical faculties which are there for you guys and taking care for every examination, that could be GATE or ESE or any ISRO or any other examination. Okay, at present for all the 2022 aspirants, I could say this is the best possible batch for you guys, because this will be giving you a complete feeling of GATE examination, that is a practice. Fine, chalo. So let's start with the heat transfer. So before starting the heat transfer subject, let me quickly brief you about which are the very important topics that you should not be skipping out at this moment. If you are not yet started heat transfer, I would say just cover up these topics. You will be covering 80% or 85% of the subject for GATE perspective. Okay, so very important, that is resistance analogy. Very important, you need to cover this topic, and we'll be covering this in today's segment. Okay, it's a very important topic. Every year one question definitely is coming from this particular segment. After this, if I say heat generation, it's not a regularly asked, but yes, for the last 5 years, if I say, the number of questions that is being asked from this particular topic has been relatively increased, right? After this, if I say topic wise, I'm not going for sequence wise or like preference wise, I'm going for the subject sequence wise. After this, if you need to cover up is your we can say heat exchanger. Okay, heat exchanger is very important. Alternate years is being asked about the heat exchanger. Next is radiation. If I talk about radiation, shape factors, shape factor or view factor, they are asking for 1 marks, not more than that. 1 or 2 questions you can expect from shape factor and radiation shielding, also important segment. After this, we can go for like lumped heat. Lumped heat, only 1 question if they're asking. Okay, if they're asking 1 question and that too of 2 marks, they'll be asking for only 1 question and that too of 2 marks. Okay, apart from this, if I talk about convection, after every 2 or 3 years or every alternate years, we can expect convection question, and they're asking only 1 problem, and that could be from heat transfer. Okay, specifically they're asking from flat plates. Specifically they're asking from the flat plates, lesser from the flow through pipe, because that question is relatively very easier to ask. And if I talk about convection, they are asking questions from heat transfer. If they're asking from turbulent flow, they'll be definitely giving you the empirical formulas, because turbulent flow, every textbooks are having multiple formulation, so they'll be providing you for turbulent flow, but laminar flow, you should be knowing the concepts and you should be knowing the relation also. Okay, at max, if I say like 4 to 6 at max, not more than that. 6 is the maximum marks that you can expect from the heat transfer, and that 4 is the minimum marks. So 4 to 6, and that too you can easily secure 5 marks easily. If they're asking from 6 marks, you can easily secure 4 to 5 marks if you are covering these important segments. Only if you are covering these topics, you are basically having the complete, I would rather say 90% completion of the subject, right? Hello Ankit, good afternoon. After a long time, fins is not that much of importance. You should be knowing about the temperature profile and also the temperature. If I want to calculate temperature at in length, that problem you need to cover, right? Fine. So let's talk about today's segment, that is resistance analogy. For understanding resistance analogy, you should be knowing what is Fourier law of heat conduction. Anyone? Because we have studied number of times this particular law, which is the governing equation for heat conduction. Anyone who can help me out in this Fourier's law of heat conduction? What is Fourier's law of heat conduction? It tells us about the rate of heat flow is directly proportional to the temperature gradient and also directly proportional to the perpendicular to the direction of heat flow, the cross section area, right? हाँ बिल्कुल, अब थोड़ी सी क्लासेस कम है, राइट? वी आर मोर इंक्लाइन टुवर्ड्स पेड कोर्सेज राइट नाउ, है ना? तो डोंट वरी, बट स्टिल वी आर हैविंग रेगुलरली ऑन यूट्यूब, बारी बारी से सब लोग क्लासेस कर रहे हैं. सो एवरी फैकल्टी विल बी सीइंग आफ्टर 4 to 5 days, राइट? अभी जैसे मेरे क्लासेस, आफ्टर माय क्लासेस विल बी सीइंग द अदर फैकल्टी, सो इट्स अ रोटेशन बेसिस. सो राइट, चलिए. So what is Fourier's law of heat conduction? Just now I told you Fourier's heat conduction is known as the rate of heat transfer is directly proportional to the temperature gradient, okay, and also directly proportional to the area perpendicular to the direction of heat flow. Okay, and if I remove this proportionality sign, this will be equal to minus K cross section area del T by del X. Okay, and why we are using this negative sign? Because heat always flows from high temperature to low temperature. Okay, because heat always flows from high temperature to low temperature, right? This is the direction of heat, high to low. And obviously, if I talk about delta T will be T final minus T initial, that is TL minus TH, which will always be a negative sign. So always the heat flow direction is in the decreasing temperature gradient, or we can say in the decreasing temperature, right? In the decreasing temperature, the heat will always flow. So that is the reason, because temperature gradient is always negative, that is the reason we are taking this negative sign in order to get a positive value of the heat flow. Okay. Yes, so we have already studied about this Fourier law of heat conduction, right? Any doubt in this about cross section area, where K is thermal conductivity, K is thermal conductivity, which is the thermophysical property of the material. The unit is watt per meter Kelvin. AC is cross section area, cross sectional area, right? Obviously unit will be in meter square, and del T by del X is the temperature gradient. This is temperature gradient, which is always negative in the direction of heat flow. Okay, which is always negative in the direction of heat flow, right? And please make sure you are liking this session, because I want a 1:1 like ratio. Yes, K is dependent on temperature. That is why I'm saying thermophysical property. I told you, right? Thermophysical property. Thermophysical property. Okay? Thermophysical property means a property which is temperature dependent. Can you tell me what are the different thermophysical properties? There are in total 4 different thermophysical properties, that is thermal conductivity, density, viscosity, and your specific heat. These are the 4 different thermophysical properties which is temperature dependent. You can see density. If you increase the temperature of air, what will happen? What is the density of air? What will happen? It will becomes less dense, right? And that is a significant phenomena for free convection, because whenever there is a temperature rise or decrease, there's a change in density happening, and due to change in density there is a buoyancy effect, and due to buoyancy effect there is a free convection process happening. Okay, so obviously these are the 4 distinct we can say properties which are temperature dependent. Fine, but today's segment is not about thermal conductivity, it's all about resistance analogy. Now, why I'm saying this is an important topic, because every year it is being seen that one question short is coming from resistance analogy. Okay, one question every year they're asking from resistance analogy. That is why I've taken up only those selected topics which is very much relevant and important for GATE examination, right? Because we all have promised you 50 plus marks. Definitely you will be getting this 50 plus marks if you are serious enough for all these sessions, not only for 1 or 2 subjects, all the segments that we are covering in this particular series. Okay, chalo. Now, if I talk about, let us suppose I'm having a slab. Okay, I'm having a slab. One side temperature is T1, other side temperature is T2, and heat is flowing from T1 to T2. Okay, this is a slab where the heat is flowing from T1 to T2, so that T1 is greater than that of T2. Then only you are having the heat flow, right? So, if I say, let us suppose, if I draw a 3-dimensional view. If I draw a 3-dimensional slab, let's say this is the 3-dimensional slab. Okay, this is a dimension A, this is a dimension B, and this is a dimension C. So can you tell me what will be the cross section area? Because many times many students are having confusion for calculation of cross section area. So what will be the cross section area in this particular diagram? The heat is flowing from T1 to T2. The heat is flowing from T1 to T2. Can anyone tell me what will be the cross section area? This will be the cross section area, right? This portion will be the cross section area, that is A into B. A into B will be the cross section area, right? Okay. Crazy view, please check right now. Now, okay, perfect, fine. Now, how to calculate heat transfer for slab, for hollow cylinder, for a hollow sphere, that will also be discussed, and after that we'll be going for the resistance analogy. Okay, so let us go for a single slab. Just now we have taken up, let us suppose the length is L, and at a distance x I'm calculating, what is the rate of heat transfer. Fine. So I can say Q is equal to minus K into cross section area is constant for the entire rate of heat transfer, del T by del X. Integrating both the side, I'll be getting Q is equal to minus K into cross section area T2 minus T1 by L. Okay, or I can say K into cross section area T1 minus T2 by L. Okay, this is the heat transfer through a single slab. This is the heat transfer through a single slab. Okay, but why this is important? Because we have to understand the concept using electrical analogy. So quickly tell me, who is this scientist? Have you seen this scientist? His name is George Simon Ohm. He has given us a very famous and very important law which is helping us to calculate very difficult numericals by using a very simple concept. Okay, he has given very important, that is Ohm's law. He has given a very important law, that is Ohm's law. And what does this Ohm's law stated? That if there is a voltage difference, then there will always be a current flow and will be having through a resistance R. Okay, V is equal to IR, or I can say current flow is equal to voltage difference by the resistance. Right? This was the basic principle given by George Simon Ohms, he was a German scientist, and till today we are using his concept in basic electrical subject. I hope so everyone have studied about this Ohm's law in your first year basic electrical. Now what we'll be doing, we'll be using the same concept, over here. Let us suppose, in order to have a current flow, you should be having a voltage difference, right? I is equal to delta V by R, which was given by the Ohms. Okay. Now here what is happening? Let us suppose T1 is greater than T2. In order to have a current flow, we always need to have a temperature difference. If T1 is greater than T2, then we'll be having current heat flow from temperature T1 to T2, right? So if you rewrite this expression, Q is equal to K into cross section area into T1 minus T2, that is, take it as delta T divided by L. Rearrange this equation, delta T divided by L by K into cross section area into Q. Now if you see this relation, and if I make an analogy, what do you mean by analogy? Analogy means, anyone who can tell me what is the meaning of analogy? Analogy basically means comparison. We are comparing the electrical concept over the thermal concept. So here we are having a voltage difference is equivalent to the temperature difference, because these quite are similar with each other. If I talk about current flow, this is quite similar to the heat transfer. Okay, so if you see delta V, delta T, I, Q, so this complete entity, we call it as a new resistance, or new parameter, we call it as thermal resistance, or I can say RTH is equal to L by K upon cross section area. Very, very important. Very, very important. So I can say the thermal resistance, or conductive resistance, that is denoted as RTH, is equal to L by K into cross section area. The meaning is, if a body is having a higher thermal conductivity, definitely its resistance will be very, very less. If a body is having less thermal conductivity, its resistance will be very, very high. The perfect example is, let us suppose I'm having a rectangular wood. We're having a wood, same configuration, I'm having a copper. Okay, same length, same cross section area. Okay, so definitely if I talk about the thermal resistance for wood will be very higher than that of thermal resistance of copper, and that is the reason the heat flow through the wood is very less, because the thermal conductivity of the wood is far more less than that of the thermal conductivity of the copper. Is this clear? Is this clear? Yes? Anyone having any doubt? So if I say, let us suppose 1 marks question regular being asked. Let us suppose I'm having a rod which is made up of, let's say, wood only, and second is made up of silver, and third is made up of let's say copper. Okay, and all the, on one side, the left side, the temperature is maintained at T, and on the other side it is T1, here it's T2, and here it's T3, and here temperature difference is delta T1, delta T2, and delta T3. All three are identical with each other. All three are identical with each other. So can you tell me which of the temperatures on the right hand side will be having a higher value? Yes. Which of the rod will be having a higher temperature? T1, T2, T3. What will be the increasing or decreasing order? Can anyone tell me which will be having the highest value in temperatures, T1, T2, T3, and which will be having the least value? Anyone? In the comment section you need to respond, and with the response please make sure you are giving a like right now. Chaliye quickly. Crazy View, Bhavya, COC expert. Okay. ZK, which is having the highest temperature, T1, T2 or T3, and which is the lowest? Left hand side is maintained at the same temperature, that is T. All are having the same length and same cross section area. All are having same cross section area, same length, everything is same, identical. Okay, so copper will be having the highest temperature. Perfect. Copper or silver? Exactly. Because the thermal conductivity of the silver is the highest. Okay, thermal conductivity of the silver is highest, and that is the reason the temperature on the right hand side of the silver will be highest. So K of silver is higher than that of K of copper, than that of K of wood, right? So I can directly say that T1 or I would say T3 is highest than that of, sorry, T2 is highest, then T3, then T1. 2, 3, 1. Silver, copper, and the wood, obviously. But can you tell me, if I talk about temperature difference point of view, which will be having the highest difference and which will be having the least temperature difference? If I talk about temperature difference point of view, which will be having the highest temperature difference and which will be having the least temperature difference? Anyone? Because there's always a confusion for every student. If I talk about delta T temperature difference, which will be having the highest and which will be having the least? Yes. Wood will be having the highest temperature difference. Delta T for wood will be highest than that of delta T of copper, right? Then we'll be having delta T of silver, right? Yes. है ना? Perfect. So always remember, silver will be having the least temperature difference, and the wood will be having the highest temperature difference if I talk about these three examples. Okay, clear? Very good. Surya, Arun, Bhavya, Crazy View. Yes, done. Okay, now this, if I talk about, this is for a single slab, very easy. But what will happen if you're having a composite slab? Composite slab means we are having two different bodies having thermal conductivity K1 and K2 being connected, having temperature T1, T2 and T3. Okay, having three temperatures T1, T2 and T3. Now in this case, we have to remember, on the back of the mind, you should be remembering about this person. Okay, you should be remembering about this particular person. that is George Simon Ohm. What you have to do is, you need to first of all identify how many temperature differences are there. We're having two temperature difference. In total, they're having three temperature, T1, T2 and T3. So I can write it like this. We're having a one resistance and second resistance over here. We're having in total two resistance. Okay, because there's a temperature difference over here, a temperature difference over here. So definitely, as this is connected in a series connection, same heat will be flowing, just like in electrical engineering, same current will be flowing for the series connection. So I can say we'll be having, let's say this is RTH1 and this is RTH2. So can you tell me, I think you're not able to see, right? Let me change the color. Hello? Now it is visible, right? This is RTH1, this is RTH2. So can anyone tell me what is the value of RTH1? What is the value of RTH1? RTH1 will be equal to L1 by K1. Let us suppose the cross section area is AC. Cross section area is AC, so it is AC. What will be RTH2? That will be equal to L2 by K2 into cross section area, that is AC, and both are connected in series. So I can definitely say that heat transfer is equal to T1 minus T3 divided by RTH1 plus RTH2, total resistance, because these are connected in series. Okay, it is also equal to T1 minus T2 divided by RTH1. This is also equal to T2 minus T3 divided by RTH2. Yes or no? Yes or no? Why I'm saying this? Because many times the question is being asked, calculate the interface temperature, that is T2. Many times, number of times GATE examination, they have asked for 1 marks also and for 2 marks also, what is the interface temperature. Many times you pick up last 10 years, definitely you can expect in last 10 years minimum of 8 to 9 times this question was asked. Okay, values will be changed, some other profile will be changing, but ultimately they are asking the same question, right? Then you can use any two relations. If they are not giving the heat transfer, then you have to bound to use this relation. If they're giving the heat transfer, you can use any one of the relations, right? But the problem rises is, what will happen if you're having a condition like this? Because here we are now including the convection part. Previous one we were not taking any convection part. Here the convection part will also be coming into the picture. Before understanding this segment, let us first of all understand the convection. Let us understand the segment of convection. Now what is convection? Anyone who can tell me what do you mean by convection? Convection heat transfer? Quickly, what is convection heat transfer? Convection heat transfer is basically when there is a heat transfer from a solid surface to the surrounding fluid, and when there is a temperature difference, there will be having a convection heat transfer. Already we have seen. And the governing law for this convection heat transfer is Newton's law of cooling. Newton is present everywhere in every subject, right? So according to Newton's law of cooling, he stated that the heat transfer, let us say I'm having a flat plate, right? Let's say this is temperature T1 and the ambient temperature is T infinity. So let's say this is Ts. Okay, so from a surface to the surrounding fluid, whenever there is a heat exchange or heat transfer occurring, that is called as convection heat transfer. Exactly, from surface to the surrounding fluid. So it is equal to H into the surface area, that means the exposed area into temperature difference. If I say surface temperature is higher than that of the ambient temperature, then this will be the formulation. If ambient temperature is higher than that of the surface temperature, in that case it will be T infinity minus Ts, vice versa is applicable. H into A into delta T, this is the convection heat transfer. So again I can say this is equal to Q is equal to HA into delta T. In short, I can say that is equal to delta T divided by 1 upon H into A. I can rewrite this equation. If you remember again our famous scientist, that is George Simon Ohm. George Simon Ohm, he has given V is equal to IR. So current flow is equal to voltage difference by resistance. Comparing these values, I can say the convective resistance is equal to 1 upon H into A. Now we have understood the convective resistance. Now coming back to this example, where it's a combination of convection and conduction. How it is happening? Let us suppose there is a ambient temperature is, let's say this is T infinity 1, having H1 as a convective heat transfer coefficient. There will be a convection heat transfer. Okay, this is Q convection, right? Then we'll be having a conduction. We'll be having a conduction. This is Q conduction. And again, this is inside the room. So definitely from the wall surface to the surrounding, we'll be having the convection, right? So if I say this is T infinity 1, T1, T2 and T infinity 2, H2. सर गेट में 70-75 मार्क्स पे कौन सा पीस मिलता है? सो डिस्टर्ब यू साहिल, देखो इट डिपेंड्स अपॉन कि व्हाट इज द डिफिकल्टी लेवल. अगर पेपर डिफिकल्ट हुआ 70-75 मार्क्स में, यू विल बी गेटिंग अ वेरी गुड रैंक. पेपर बिकम्स इजी, देन यू हैव टू सिक्योर एटलीस्ट 85 प्लस टू गेट इनटू द पीएसयू, है ना. It doesn't depend upon how much marks you are securing. It depends upon the difficulty level and the rank you are getting, because it's all, we can say, relative term. ठीक है, because let us suppose the paper is difficult, the topper is not able to, let's suppose the topper के marks is 85, so definitely 70 to 75 marks will be like very good, you will be getting a very good rank, है ना. Fine. So it doesn't, we cannot say directly like if you're securing 70-75 you will be getting PSU. You can get, if it depends upon the difficulty level, right? Chalo. So here we can say we are having how many resistance? Yes. How many resistance we are having? Now from T infinity to T1 we'll be having one resistance. Okay. From T1 to T2 we'll be having the second resistance. From T2 to T infinity 2 we'll be having the third resistance. So we'll be having one conduction resistance. Okay. Two convective resistance, convective 1 and convective 2. So this is T infinity 1, this is T1, this is T2, this is T infinity 2. Now my question is, sir, from T1 to T2 we are having a conduction happening, so we can use Fourier's law of heat conduction. Okay, from T infinity 1 to T1 or T2 to T infinity 2 we are having a convection going on, so we can use convective heat or Newton's law of cooling. But sir, can you tell me from T infinity 1 to T infinity 2 what is the mode of heat transfer? From T infinity 1 to T infinity 2 what is the mode of heat transfer? Which governing law we need to apply? Do I need to apply Fourier's law or do I need to apply Newton's law of cooling? How we can identify that? Anyone? Sir, we can use Fourier's law. Sir, we can use Newton's law of cooling because there are 2 times convection happening. Is that so? Yes, everyone. Respond in the comment section what we have to do. What we have to do in order to calculate the heat transfer. Ohm's law. Okay, perfect. We have to go for Ohm's law. We can go for Ohm's law, right? But ultimately, if I want to calculate heat transfer, then what I have to do? You can go for like this: Q is equal to T infinity 1 minus T infinity 2 divided by the total resistance. You can go for this. You can go for this. You can calculate. Right? You can calculate this. You can calculate the heat transfer. But ultimately, if I say, if anyone is asking you, sir, if I want to calculate the heat transfer, so shall I prefer Newton's law of cooling or Fourier's law? What will be your response? In that case, we won't be using Fourier's law, we won't be using Newton's law, we will be introducing a new parameter. We'll be introducing a new parameter, and that parameter is called overall heat transfer coefficient. That parameter is called overall heat transfer coefficient, denoted by U. Okay, that parameter is called overall heat transfer coefficient, which is denoted by U. So whenever there is a multiple mode of heat transfer occurring in a single system, Okay, and if I want to convert it into a single entity, I'll be using a parameter, and this parameter we call it as overall heat transfer coefficient. Okay, and it is being seen that Q is equal to U into A into delta T. Okay, that means if I want to write it like this is also equal to U into A into delta T. Or I can write this as delta T divided by 1 upon U into A. So can I say like this, 1 upon overall heat transfer coefficient into area is equal to R total? Because this will be quite helpful when we'll be discussing the heat exchanger topic. Because in heat exchanger, we'll be effectively using this overall heat transfer coefficient concept in order to calculate the fouling factor. If you remember the concept of fouling factor in heat exchangers, there it is quite useful. Okay, so now I can say that if I want to calculate the total heat transfer, I can calculate the overall heat transfer coefficient, use this concept and get the heat transfer. Okay, is this clear? If you are not knowing the individual components but they are giving you overall heat transfer coefficient, then you can directly get the value of heat transfer by using U into A into delta T. U into A into delta T. Is this clear? Yes. Okay. Overall heat transfer coefficient. Any doubt? Because this was about the slab. This was about the slab that we were discussing. But what will happen if you're having a hollow cylinder? What will happen to the hollow cylinder? Now, before going for the hollow cylinder, let me quickly tell you about single slab. Very important thing that we have not yet discussed. When we were discussing for a single slab, right? So what was happening is the heat transfer was going on from T1 to T2. The temperature profile was a straight line. How we can say? Look, Q is equal to minus K into A into del T by del X. Okay, so if you integrate, I can say Q is equal to minus K A T into X. That means T is directly proportional to X. That means the temperature will decrease along in linear fashion. Temperature will decrease in a linearly decrease. That is why I have drawn the temperature profile to be a straight line for a single slab. I have drawn the temperature profile linearly for the single slab. Okay, or for a slab. But if I talk about hollow cylinder, let us suppose I'm having a hollow cylinder whose inner radius is R1 and outer radius is R2. Inner radius is R1, outer radius is R2. The temperature is T2 on the, let's say, this is the temperature T2 and this is the temperature T1. This is a hollow cylinder and this is the thermal conductivity K of the solid. So if I want to calculate it, suppose Q is equal to minus K into, let us suppose I'm taking at any radius R, the length is L. So it will be 2 pi R into L as the area into del T by del R. So if you integrate, we'll be having Q is equal to minus 2 pi KL delta T divided by ln R2 by R1. Right? So if you take the negative sign inside, your delta T changes. It will be T1 minus T2. Okay, right? So if you change this expression, Q is equal to delta T divided by ln R2 by R1 divided by 2 pi KL. So this parameter in the denominator, this will be telling us about the convective resistance. This is nothing but the, conductive resistance for a hollow cylinder. That is ln R2 by R1 divided by 2 pi KL. A is area. Let me tell you about this area after this. Hana? Clear? So this is the conductive resistance for a hollow cylinder, and here the temperature varies logarithmic to radius r. Okay, and that is the reason we will be drawing the temperature profile in a logarithmic fashion, not a linear fashion, just like in the slab. In slab, what we are doing, we were drawing a linear variation with respect to the distance. Here the temperature varies in a logarithmic fashion with respect to radius. Okay. Now, if I go back to this overall heat transfer coefficient, the A is the area exposed. If I say this as the slab, this is the convection, this is conduction, and this is again convection, this is conduction, and this is convection, right? So what is happening? This area, the cross section area, will be acting as the cross section area. This area will be acting as the cross section area, and this is the exposed area. So this is area A, this will be the exposed area for convection, and this will be the cross section area for conduction, and same area will be for the convection exposed area for the right hand side. So this area is nothing but the exposed area. But sometimes what happens when I talk about hollow cylinder, there we were having internal convective heat transfer coefficient or outer convective overall heat transfer coefficient. If I say, if you're having a hollow cylinder, let us suppose I'm having a hollow cylinder, okay, right? Let us suppose in or outside we are having a fluid which is having thermal convective heat transfer coefficient as H, temperature is T infinity, okay, and let's say this is H2 and this is T infinity 2, and here we are having T infinity 1 and this is H1. So here what we will be discussing is, we can classify the R total. The total resistance will be, what will be total resistance? We will be having three resistance. One is convective resistance on the center or on the inner side of the hollow cylinder. One will be convective resistance over here inside the fluid. We will be having conduction over here, and again convection over here. Okay, so we are having three resistance. Let us suppose this is T infinity 1, this is T1, this is T2. So T infinity 1 to T1, then we are having T1 to T2 and T2 to T infinity 2. So we are having a convective resistance, we are having a conductive resistance, and we are having a convective resistance 2. This is 1. So quickly tell me, what will be the convective resistance 1? What will be convective resistance 1? See the diagram and tell me what is a convective resistance 1. There you will be able to understand the overall heat transfer coefficient concept. It will be 1 upon H1 into, what will be area? What will be area? What will be the area? It will be the surface area, that will be equal to 2 pi R1 into L. 2 pi R1 into L. Area will be 2 pi R1 into L, that is the surface area of the inner cylinder. If I talk about conductive resistance, it is logarithmic functions ln R2 by R1 divided by 2 pi K into L. And if I talk about the convective resistance 2, that will be equal to 1 upon H2, the outer, because the convection is happening on the outer surface, from this surface, right? From this surface. I'm not taking the cross section part. So it will be H2 into 2 pi R2 into L. Yes. So if I want to calculate total resistance, that will be the summation of convective 1 plus conductive plus convective 2, right? This will be the total resistance of a hollow cylinder. Yes or no? And what was overall heat transfer coefficient? Overall heat transfer coefficient was nothing but, you can see over here, it was equal to the total, 1 upon UA is equal to R total. Now the problem is, sir, how we can define the overall heat transfer coefficient over here? Because there are two areas, two surface areas, the inner surface area and the outer surface area. So in that case, what will we do? We define two overall heat transfer coefficient. This is inner overall heat transfer coefficient and UO is outer overall heat transfer coefficient. That means with respect to the outer surface, and UI is with respect to the inner surface. So I can say UI AI is equal to R total, and this is also equal to 1 upon UO into AO. Clear hai? Yes. So in that case, we are able to distinguish between which area we need to take. If I'm considering with respect to inner surface, you have to go for inner surface area. If you're distinguishing with respect to the outer surface, you have to take the outer surface area. But this was not applicable in the slab, because in the slab we are having the same area. If I say this is the exposed area, okay, this is the cross section area and this is the exposed area. So basically the area was same. So that is why we were not having any problem for area, which area we need to consider. But in case of hollow cylinder, we were having this problem of inner and outer surface area. That is why we have defined two overall heat transfer coefficient with respect to inner side and with respect to the outer side. Clear? Understood? For hollow cylinder, Dheeraj, understood? Yes, very easy, very important. This is, I already responded, this is important from heat exchanger perspective, because in heat exchanger we are using this concept of inner overall heat transfer coefficient and outer overall heat transfer coefficient. Chali, now let us discuss about hollow sphere. Let us discuss about hollow sphere. Let us suppose this is R1 and this is R2. So this is R1 and this is R2, this is D1 and D2, right? I am taking any radius R, and what will be the surface area of this? The surface area will be equal to, yes, 4 pi r square. The surface area of sphere is 4 pi r square. So I can write Q is equal to minus K into 4 pi r square del T by del R, integrating both the side. I'll be getting Q is equal to delta T divided by 1 upon R1 minus 1 upon R2 divided by 4 pi K. So this denominator that you are seeing, that is the conductive resistance for a, this is the conductive resistance for a hollow sphere. Okay. Clear? Rarely asked. Hollow sphere or hollow sphere is like negligibly asked in the examination, but hollow cylinder and definitely your composite slab is very, very important from exam perspective. Okay, fine. So let's solve some questions so that you are having better understanding of for the examination, because if you're not solving questions, basically you're not practicing, you're not able to cross check how much you have understood. So let us solve one MSQ problem. This is an MSQ problem. This is an MSQ problem for GATE exams perspective. So what is happening is we are having two slabs. The length, if you are not able to see, this is 0.1 meter and this is 0.15 meter, right? Okay, 0.1 meter, 0.15 meter. Heat flux is given 7800 watt per meter square as shown in the figure. The temperature on the left hand side is 168 degrees Celsius. The temperature on the right hand side is 38 degrees Celsius. KB by Ka is given as 0.75. So tell me which of the options are correct. Which of the options are correct? Quickly calculate and tell me. Quickly calculate and tell me the interface temperature, that is TB. Temperature gradient in slab A is more than that of slab B. Temperature gradient of slab B is more than that of slab A. The ratio of thermal resistance in slab A to B. Easy question, very easy question. Take out your calculators. I think calculators also no need to use. You can solve it very easily. Now they are directly saying heat flux, right? But they are not mentioning the values of K. They are giving the ratio. So what we can do is, we can take, because these are series connection, so same heat will be flowing. So I can say TA minus TB divided by resistance is 0.1 by Ka into A is equal to TB minus TC divided by 0.15 by KB into A. A say A cancel, right? TA is given, TC is given. You can get the value of TB. Yes, quickly. This is 0.1 meter. Yeah, this is 0.1 meter. This is 0.1 meter. Block A is 0.1 meter. Block B is 0.15 meter. Okay. Quickly. Yes, Bhavya. Absolutely correct. It's 0.1 meter. Use this relation and tell me what's the value of TB. Are we getting 124.66? Please cross check. Only now calculation part is left out. TA is given as 168. 168 minus TB into KB divided by 0.1 is equal to, sorry, this is Ka, na? Ka. Ka is equal to TB minus temperature is 38 into KB divided by 0.15. KB by K is given as 0.75. You can use this. So 168 minus TB is equal to 0.75 into TB minus 38 divided by 1.5. Chaliye, quickly calculate the value of TB and tell me what's the value you are getting. Calculate the value of TB. Done. You'll be getting exactly the value of TB to be 124.66. You'll be getting the value of TB to be 124.66. Option A is the correct answer. Okay. Now these two are connected in we can say series connection. So I can say same heat is flowing. Q is equal to minus K cross section area del T by del X. So I can say cross section area and K into del T by del X is constant. This value is constant for both the slab. Here Ka is greater than Kb. So can we say delta T X of B is greater than that of delta T by delta X for A? Because thermal conductivity, the body which is having higher thermal conductivity will be having a lesser temperature gradient. So from this particular concept, I can directly say that option C is correct and option B is incorrect. Obviously, because same heat is flowing, same cross section area, so K into delta Tx is constant for both the slab. The product is constant. So the body which is having higher thermal conductivity, definitely it will be having a lesser temperature gradient. So from that fundamental, we can directly say option C is correct. The last option D they're asking is the ratio of thermal resistance in a slab A to B. That means RTH for slab A divided by RTH for slab B. So this is 0.1 by Ka into cross section area A divided by 0.15 divided by Kb into A. So this will be Kb by Ka into 0.1 by 0.15. So this is 0.75 into 0.1 by 0.15. Tell me what's the value you're getting. You'll be getting exactly 0.5, I think. Option D is also the correct answer. So from this particular question, you will be getting A, C and D as a correct answer. A, C, D is the correct answer. MSQ problem, very important, because last year there was not a single MSQ. So you can definitely expect MSQ question in 2022. Okay? MSQ problem you can definitely expect in 2022. So make sure now you are ready for that. Last year it was just introduced, so that is why they they have not had that importance to give in the examination. But this year, that is 2022, you can expect at least 2 to 3 questions as an MSQ. Sir, option C repeat कर दीजिए एक बार. हाँ, definitely. देखो ये देखिए, देखो ये there are 2 slabs, है ना? There are 2 slabs. This is slab A, this is slab B. Same heat is flowing, same cross section area for both the case, है ना? Q is equal to minus K cross section area del T by del X, right? Q is constant दोनों के लिए, cross section area is constant for both A and B. So I can say K into del T by del X, Ka del T by del X of A is equal to Kb del T by del X of B, है ना? So I can say if Ka is greater than Kb, so I can say del T by del X of A is less than del T by del X of B. Yes or no? Yes or no? है ना? Because the body which is having higher thermal conductivity, definitely uska temperature gradient will be having lesser value. Because if having same heat transfer, देखो Q is constant, A cross section is constant, so Ka del T by del X for A is equal to Kb del T by del X for B. Ka is greater than Kb, so I can directly say delta T of X for A is less than that of delta Tx for B. Okay, so from that B was cancelled out and C was the correct answer, and obviously option D you have calculated, it was coming out to be 0.5. Clear? Can we go for the next problem? Chaliye, next question on your screen. A wall of thermal conductivity 0.7 watt per meter Kelvin transfers 70% of the heat loss compared to the other wall having K is equal to 0.4. Length is 50 mm. The temperature difference is 1.2 times than that of the other wall. Find the thickness of the first wall. So let us suppose we are having two walls. Let's say this is having L1 and this is L2. This is L2. This is K1, this is K2. So K1 is given as 0.7, K2 is given as 0.4, X2 is given as 50 mm. Okay, delta T1 is equal to 1.2 times of delta T2 and Q1 is equal to 0.7 of Q2. Use this relation and tell me what is the value of L1. What is the value of L1? Quickly. Use Fourier's law, take the ratio, or you can directly use, because this is given. So Q is K1 into area is same, I think, right? Area is same for both the cases because they are not mentioned. So definitely the area is same. It will be del T, or I can say delta T1 by L1 is equal to K2 delta T2 by L2. हाँ, same cross section. Right, because they are not mentioning anything about cross section here, so you have to take the same cross section. Right? Chaliye, quickly. K1 is 0.7, T1 is 1.2 of delta T2. Divided by L1 you have to calculate. K2 is 0.4, delta T2, L2 is 50, right? Chaliye, quickly calculate the value of L1. What is the value of L1 you are getting? And 0.7. Because it was 70% less, so 0.7 of that. You have to take this 0.7, right? Quickly. So this 0.7 and 0.7 cancel out. L1 comes out to be 1.2 into 50 by 0.4. So this comes out to be 150. Are we getting 150 mm? No calculator required. NAT problem hai. Are we getting 150 mm? Yes or no? Quickly. Solve the question. Easy question, guys. Very easy question. Quickly. Chalo. Next. Question number 3. Let's proceed quickly because there is one more NAT problem. Because I'll be giving you one homework question also that you have to respond in the comment section. On the YouTube, and we'll be discussing the homework question in the next class also, right? Chaliye, two sheets of thickness 2 mm are placed in contact with each other, having numbered 1 and the outer plate is plate 1 maintained at 373 Kelvin and that of plate 2 maintained at 253 Kelvin. What is the temperature at the interface? Very easy, very easy, guys. Exactly, very easy. So we're having two plates 1 and 2, right? This is K1, this is K2, this is 373 Kelvin, this is 253 Kelvin. K1 by K2 is given as 3:1. Two sheets of thickness 2 mm. So both are having the same thickness, that is 2 mm each. What is the interface temperature? What is this interface temperature? Quickly. What is the interface temperature? Quickly. Both are having the same thickness of 2 centimeter. You can directly take it as L. L is equal to 2 centimeter. Use the concept. Very easy. So I can say temperature difference, series connection है 373 minus T, this is equal to L by Ka, L by K1 into area A is equal to T minus 253 divided by L by K2 into A. L cancel out, A cancel out, right? K1 by K3, K1 by K3 is 3. So 3 into 373 minus T initial, T interface minus 253. Solve it and tell me what is the value of Ti you are getting. Solve it and tell me what is the value of Ti you are getting in Kelvin. What is the value of Ti you are getting in Kelvin? NAT problem hai, easily you can get. Done? Very good, very good. We'll be getting 343 Kelvin. Same question was asked in GATE examination for 2 marks 3 years back, 2019 or 18 or 17 or 18. Same question for 2 marks NAT problem. Very easy. Okay, so now you can easily calculate the interface temperature to 343 Kelvin. Done? Clear hai? Yes or no? Very, very easy questions, guys. Question number 4 on your screen. A composite wall consists of 3 different materials having thermal conductivity K, 2K and 4K respectively. The temperature drop in each material is same, then the thickness of material will be in the ratio of. There are 3 composite bodies. Okay, there are 3 composite bodies. Let's say this is L1, L2, L3. This is K1, K2, K3. Okay, delta T is same for each. So what is the ratio of L1 is to L2 is to L3? A, B, C or D? Very good. Simple है देखो, same heat will be flowing. Whenever you are having any question from the composite wall, always see the series connection. Q is equal to K into cross section area into del T by L. Okay. So I can say K by L is constant because Q is constant, Q is same, delta T is same, cross section area is same. So K by L is constant, or I can say K is directly proportional to L. So in the ratio K is being distributed, and the ratio how the K is being, K is having the ratio, same ratio will be having the thickness. Yes or no? Temperature drop is same, the thickness will be in the ratio of, tell me. Option A is the correct answer. Very good, Swami. Option A is the correct answer because in the same ratio, the thickness will be distributed. Right? Because temperature drop is same. I'm not talking about temperature drop ratio. I'm talking about thickness ratio having same temperature drop. Okay. So Q is same, cross section area is same, delta T is also same. So we'll be having the same ratio as that of the thermal conductivity, that is 1:2:4. Same ratio will be for the thickness, that is 1:2:4. Okay, exactly. Very good. Crazy View and Bhavya, is this clear? Is this clear? Important question hai because these type of question is being regularly asked in examinations. Easy question, straightforward questions in GATE examination from this particular subject of heat transfer. Clear? Understood? Option A is absolutely correct. C is incorrect. Okay, chalo. So this is a homework question. This is a homework question, question number 5th. Please make sure you are writing your answer in the comment section. Okay, I hope so. You are able to see the diagram clearly, right? You're able to see the diagram clearly. So we're having two slabs in series. Temperature is given 130 on one side and 30 on the other side. Ka is 20, Kb is 100. One is having 0.1 meter and second is having 0.3 meter thickness. You have to calculate what is the interface temperature. ठीक है, यू हैव टू कैलकुलेट व्हाट इज द इंटरफेस टेम्परेचर. बहुत ही इंटरेस्टिंग है, इंपॉर्टेंट है और एक प्रीवियस ईयर क्वेश्चन जैसा लग रहा है, बट हो भी सकता है नहीं भी हो, बिकॉज वैल्यूज कैन बी चेंज राइट. सो मेक श्योर यू आर नॉट कॉपिंग दैट. कंसेप्ट को कॉपी कीजिए, डोंट कॉपी द वैल्यूज. ओके, चलिए. सो थैंक यू फॉर ज्वाइनिंग विथ मी. दिस वाज एंड फ्रॉम माय साइड एंड आई होप यू ऑल एंजॉयड राइट. चलिए, so we'll meet day after tomorrow and we'll be talking about another very important concept, that is heat generation. Heat generation भी बहुत important topic है and question is being regularly asked from that particular segment. Okay, done. चलिए, so let's catch up day after tomorrow and we'll be discussing about heat generation topic. Very important, very logical. क्वेश्चंस बहुत फ्रेम होते हैं बट नॉट रेगुलरली आस्क्ड. एवरी alternate year they are asking the question for 2 marks or even 4 marks using common or linked problems. Okay, so we'll be discussing all pattern of question, MSQ, NAT, MCQ, everything will be discussed in the tomorrow in the next class. And stay connected with this channel. 3 p.m. save the time. Day after tomorrow, heat generation topic. Okay, so thank you. Same time it will be there, 3 p.m. on this channel. And next topic that we'll be discussing is heat generation. The concepts of heat generation, very important, very unique. Questions point of view, it's very, very important. Okay, chaliye, thank you guys. Take care, stay safe and enjoy your day with BYJU'S Exam Prep. Thank you.